Well, welcome back to AM. Joining us now is Dr. Bill Deese from Louisiana Tech, and we are actually going to see some chemistry today, right,
That's
Bill?
right. I'm a chemist, so I thought we might as well do some more chemistry on the show. Yeah. And we're going to talk today about a class of compounds called carbohydrates. Okay. And what does the name carbohydrate indicate to you, Gigi? Do you think of anything
carbon, hydrogen, and oxygen? Okay,
carbon, hydrogen, and oxygen. That's right. And all carbohydrates are made from those three elements.
Right.
Okay. And this is a very common, this is a model, a molecular model of a very common carbohydrate that we consume all the time. This is table sugar. Okay. It's also called sucrose.
Right.
Okay. And if you look at that molecule, do you see anything? Is it all? You were talking a while ago about simple sugars and whatever.
And this is a disaccharide.
A disaccharide.
Because it's two simple sugars
together.
Right.
We have a glucose molecule and a fructose molecule linked together to make a disaccharide.
Okay.
So you know a lot of chemistry, don't you?
Not really.
All right. Now, we need to put our goggles on because we want to get a reaction started.
Okay.
Now, this is just table sugar, and its formula C12H22O11.
How do you keep these on your, okay.
They're going to work?
Slides down.
Are you ready?
Yeah,
okay. Now, and so I'm just going to put,
This is going to be kind of dangerous. Is that
no,
why
this is not dangerous at all. We wear the safety goggles in case this is going to create heat, this reaction.
Right.
And in case it produces heat faster than it usually does and it splatters some of that acid out,
then we sure don't want
then our eyes are going to be protected.
But our skin's history.
Well, we can wash it off our skin.
Quickly, huh?
Right. It's not a problem with our skin.
All right.
But it would be a problem with our eyes.
Right. Okay.
All right. Now, this is sulfuric acid. Have you ever heard of sulfuric acid?
I think so.
What is it?
It's battery acid.
That's right. That's the acid that's in our car batteries. And this
so you don't want to fool around with that.
Right. This is a corrosive material.
Right.
Okay. And we're going to pour some sulfuric acid onto our sugar. Okay. And we're just going to let that sit there a while, and we should notice something begin to happen. Okay.
So we're actually going to separate this molecule?
Well, okay. One property of sulfuric acid, in addition to being a good electrolyte, that's why we use it in our car batteries, it's a very good dehydrating agent. Now, when you think of something being a dehydrating agent, what do you think about? What's it doing?
Taking out the water.
Okay, it's removing water. Right. Okay. Now, remember our sugar here is C12H22O11. Okay. And another way to write that formula, notice that there's twice as many hydrogen atoms as oxygen atoms. So that's pretty much the same thing as having 12 carbon atoms and 11 water molecules. So if we were to take this molecule and break it apart into all its individual atoms, then we would have 12 carbon atoms, and that's what I have right here. These black marbles represent the carbon atoms. Okay. Then we could take all the oxygen atoms, which are represented by the red marbles, and all the hydrogens, which are represented by the white ones, and build water molecules, H2O.
Okay.
Okay. And
I'm following you so far.
All right. If we were to do all of that, then we could make 11 water molecules.
Right.
Okay. And so, where do we find carbohydrates? Who makes carbohydrates for us? Do you know that?
Plants.
Plants. That's exactly right. Green plants, during the process called photosynthesis, they take in carbon dioxide, look at here.
Oh, look.
Okay, and water, and build carbohydrates for us. And they use the energy from the sun to do that, and they store some of that energy in the molecule. Okay, and so this water, the sulfuric acid is removing the water from our sugar, and what's left behind is the black carbon. The carbon.
Look at that, and it stinks.
Yes,
it smells like
pretty bad. It smells like burned sugar, doesn't it? Okay.
Yeah, maybe a little worse than burnt sugar.
Burnt sugar. So what we have here is just carbon black, okay, and
it does stink.
The water has evaporated because of the heat of the reaction.
I am impressed.
And so, well, that's a classic demonstration that's done by science teachers all over the country.
Well, I haven't seen it in a long time. It's been a long time since I've been in a science class, but this was great. Carbon. And it does smell pretty bad.
Yes, it's really, the air conditioning's blowing it right in my face right now.
Mine too, right into my mouth. Well,
Okay.
Bill, thanks very much for joining us today and showing us how to break down this molecule.
Well, it was fun coming over.
It smells terrible. We'll be back in just a moment with more AM, so don't go away.